All right, we are back. This is Techmath1. We're looking at chapter 10. We're picking up on 10.5. That is slope-intercept form. And so that we're going to start off on page 441. So what they want us to do... Oh, got to turn on C3POs. Nice. Doing, there we go. TAC3PO ready to go. So we've got this, and it's called slope-intercept form. That means y equals mx plus b. M is slope. B is the y-intercept. And so that means that's where it crosses the y-axis, and that's like the directions from that point where it crosses the y-axis, or any point on the line. It's M for slope because Montier, the guy who invented the Cartesian plane, René Descartes, he was a Frenchman, and so that's why we use M for slope. All right, so this is already solved for y, so it's super easy to find the slope. It's the number in front of the x. That's just 3/4. And then the intercept, that's where it crosses the y-axis, so it's 0, comma, and then 8. And so that's it. That's the y-intercept, that's the slope. When it's solved for y, these are pretty straightforward problems. So this one's solved for y, so the slope is -1/2, and the y-intercept is 0, -5/4, or you could say -1.25. Probably easier as a decimal if you're graphing. All right. This one is a little tougher because you got to solve it for y first. And so they want us to put it in slope-intercept form. And then even though they don't ask for it, we'll do the slope and the intercept. So we isolate y. We want to get y by itself. So 5y is equal to -x plus 3. And then whatever's in front of the y, we want 1y equals. So you divide, divide, divide. And now remember, there's a 1 in front of the x. When there's nothing there, there's a 1 there. So it's -1/5 x plus 3/5. So we would have the slope would be -1/5, and the y-intercept would be 0, 0.6, or we'll just leave it 3/5, I guess. But like I said, when you're actually graphing, it's easier to make those into decimals, you know, so take 3 divided by 5 and get 0.6. Okay, so slope-intercept form, hopefully you've seen this already at some point. This isn't brand spanking new for you. All right, on to 10.6. They want us to do graphs of parabolas. And so I think we're going to use our graphing calculator. -2x squared plus 1. Do that one. And now for number 65, that's on page 445 in the blue book. Number 65, they want us to graph that. But they already did like an XY chart for us where they have all the points already. So -1, -5, 1, 2, 3, 4, 5 goes right there. 0, 1 goes right there. 1, 3 right there. Oh, so my lines are off. Okay, and what else do we have here? We've got 2, 1, 3, -5. And then they did 1/2, 2.5. That's a weird point, huh? 1/2 and then 2.5. It's like right there. And then they did 1.5 And that's also 2.5. That's right there. Those are weird points. Okay, so a couple of things about parabolas. Parabolas are like a U and a V had a kid. It's U-shaped, but it's got a point on it. All right, and so it's like a U that's getting wider and wider and wider and wider and wider forever, infinitely wider. But it's got a distinct point, and so like a V. And so that point is called the vertex. When it's negative 2x squared, so when the leading coefficient, when the thing on the squared term is a negative, it opens downward. So this U is getting forever larger, but it's got this point on it like a V. And so when that's negative, it opens down. When that's positive, it opens up. And then this stuff moves it, you know, right, left, up, down. And so you could do this on your graphing calculator. Show you what that looks like. Come around here. And so the old graphing calculator. So you hit this y equals, and then you get that readout right there. Oops, I gotta clear it. Okay, and so now to type in negative, remember it's the negative button, -2, and then x is right there, right next to the alpha key. It's got x, comma, t, comma, theta, comma, n. So x. So right now it says -2x, but we want it squared. Now you can do the little power and then a 2, or you can just hit the squared, x squared key. And then look, it puts a little squared on there for us. Then plus 4x, and then plus 1. Okay, so I typed it in there. You can see it's all typed in there. -2x squared plus 4x plus 1, and then you just hit graph. And I'm on a 10 by 10, and there's the same thing. You got the same picture. This one's better on the calculator than on my board, right? And so now, if I'd like to, let's say they want me to make a table with at least 10 values. Well, don't do that by hand like the pioneers. Do second and then graph. That's a table. And see, now you've got a table. So you can just copy them right off of the table. You can click upward. I'm clicking the up button or the down button, and you can get as many points as you want off of the table. Okay, and then if you want to go back to the graph, just hit graph, and it brings it right back. All right. So the graphing calculator can really make short work of all of these problems. Let's look at 66. So that's y equals x squared plus 1, and they want us to build a table. But again, unlike a line, like linear problems, it's easy to build a table because you could just pick 3 points, and it didn't really matter what 3 points you picked for the line, just as long as they all fell onto the line. With parabolas, it's a little trickier because you got to make sure that you get the vertex, you know what I mean? If I just pick, like, even if I did 5 or 6 points, well, if they were all the points just down this side and I never hit the vertex and came back down, well, then that would be a problem. I wouldn't really get a graph of a parabola like I'm supposed to. So that's where these come in. So y equals, let me delete, x squared, delete, plus 1. So I've got y equals x squared plus 1, and then I'll hit enter, and then I'll hit graph. And so I'm on that little 10 by 10, and it shows the graph of a parabola. It looks like the vertex is at 0, 1. And so we've got that right here and going up. And now they want some points on their table. And so let's make this do all the work. So we're going to hit second, and then the graph button. It's table then. And so there's a bunch of points. So we'll just grab 3 or 4 of them and put them down here, making sure that one of them is 0, 1. That's the vertex. So got to make sure that vertex is in there, but then negative 1 and 2, 1 and 2, 2 and 5, whatever you want, 3 and 10. Okay, so there you go. You can pick them if you wanted to pick them and put in X and then figure out what Y is. You could do it that way too. It's just, you've got the technology. It's a requirement to have a graphing calculator for this class. So I'm kind of under the assumption you want to use that tech. All right. Let's take a look at 10.7. So 10.7, they've got F is equal to 9/5 C plus 32, and they graphed it. This is Fahrenheit compared to Celsius. They said the slope of the line, well, okay, so they want, this is number 69 on page 448. The slope of the line is the thing in front of the variable, so 9/5. And the F-intercept for Fahrenheit is 32. Or, well, 0,32, I guess. They want it as a point. All right, and then they have it graphed. And now notice on the graph in your book, they go like 20, 40, 60. So it isn't 1, 2, 3, 4. So make note of, you know, the scale that they're using when you do graphs. All right, let's jump to 73 and then 76. And so on those two, they want you to use the graph. They already provide the graph, so they want you to use the graph and kind of work backwards on it and give them the point that matches with the information they gave. So look at 73. 73 is the 21st prime number. All right, so we've got this line going exactly vertical like this. But again, be careful of those scales. This is 1 and this is 50. So it went by 50s. Like each mark is 50 on the Y, and each is only 1 on the X. So 1 hour, 2 hours, 3 hours, 4 hours. But then, you know, this is 100 and so on. Okay, so how long will it take the car to go 100 miles? So they gave us the Y value. And so what they want you to do is click that over, and then follow it down and give them the X. So that would be 2 hours. Well, or it's 2 hours on my picture. Oh, good, it's 2 hours on their picture too. All right, how long would it take the car to drive 250 miles? So 250 miles, it's going by 50s. So 150, 200, that's 250 right there. And that's going to be 5 hours. So what you do is you just follow it across here on that point, and then you go straight down. And that's how you're using the graph to figure out the answers, okay? They also could have said the other way. They could have said, after 4 hours, how many miles would you have driven? And then you'd go to 4, follow it up to where it hits the line, and that would be 200 miles. So you're just reading the points off of the graph. Now, if you look at 76, they're doing a similar thing. Here, I'll just squeeze it in here. 76, but this time they've got the positive half of a parabola. All right, and so where this is 2, that is 20. All right, and so now it says, how far would an object fall in 3 seconds And so you go to 3 seconds, you follow it up to there, and then follow it over to there, and that's 40. That's 40 meters. It's in meters per second. So they gave us 3 seconds, and in 3 seconds it would fall 40 meters. All right, then they ask, well, how long will it take an object to fall 130? And so 130, you got to go way up the scale up here, 130 meters. And actually it's right halfway between, right? 120 and 140. So they don't have 130 marked. They got 140 and they got 120. And so you know 130 is right split in the middle of that. And then you follow it down and it turns out to be 5 seconds. It looks like about 5 seconds. Okay, so you're using the graph and the x and the y axis to figure out, you know, each one of these points is on the graph. This is 2, 20. This is 3, 40. This is 5, 130. And so they gave us either the x or the y, and then we had to use the graph to figure out where the point is and then figure out the other one. All right? So you're just kind of following back the other way. All right, so let's look at um, 10.8 functions. So in 10.8, sorry, we're looking at functions. So functions are graphs where there's never one point directly above another point. That's what makes a function a function. All right, and so when we look at number 80, they have some pictures and they want to know which ones are functions. So they say have A, there's a circle, B, there's a line that's askew, C, there's a sideways parabola. That's a square root function, actually. Oh, not a function, because it's the bottom half. All right, so now look, if you can draw a vertical line and it hits it in more than one spot, it's not a function, because then you got one point directly above another point. So this is not a function. This is not a function, because look, every vertical line I draw hits it in 2 spots except for the one at the vertex. This one, same. On the very edges of a circle, you won't hit it in 2 spots. But if you just hit it one time and it hits in 2 spots, it's not a function. So not a function, not a function. This one is a function. And that's because, look, if I draw a vertical line, I'll only hit it once. If I draw a vertical line, I'll only hit it once. If I draw a vertical line, I'll only hit it once. All right? That's called the vertical line test. But basically, you can just look at it, and if you see any points that are directly above another point, it's not a function. Okay, so let's go to 84. So 84 is tricky. Identify the domain for each function below, except 84, they kind of mess. Is that a function? Oh yeah, it's not a polynomial, but I guess it could be construed as a function. Okay. So these are kind of tough. The domain is a list of anything that X can be. All right. And so these are easier if you look at the graphs of these. So when you look at the graph of this one, it's got a vertical asymptote at 0. That means it can't be 0. You can never divide by 0. So 0 is taken out. It can't be that graph. And then let's see, if I put in 1, I get 3/5. If I put in 2, I get 3/10. If I put in 3, I get 3/15. And so I get this graph that kind of looks like this. And then if I put in -1, I get -3/5. If I put in -2, -3/10. So I get a graph. I get a weird graph that looks like that and that. All right. So off of the graph, what is the domain? Well, the domain are, all right, and we'll just write them out. I guess that's easier than function notation and stuff, interval notation. So it's all real numbers. Because look, x can be anything 1 through, and x can be anything -1 through, and even 0 to -1. All real numbers except x is not allowed to be 0. Because if you put in 0, you divide by 0, and that's not allowed. That's why there's a vertical asymptote there separating it. So it'll never, ever, ever be 0. So all real numbers except for 0. 2x squared minus 1, that's just going to be all real numbers. Because that's a parabola. There isn't no restrictions on it. It opens up. It's shifted down. It's a skinny parabola. It looks like this. But remember, it's getting wider and wider and wider and wider forever. So all real numbers. There's no restriction on what you can put in for x. You can put in anything for x. Y, the range, that would be restricted because it doesn't ever drop below -1. But they only wanted the domain, so no worries. And then this one, what's going on with that one? That would be shifted 10 to the right. And then at 10, it would be 0, and then it would be going up like this. So that's what the graph of this one looks like. That's a weird graph. It looks like half a parabola tipped on its side, but it doesn't come into existence until 10. So this is all real numbers except values of x less than 10. All right, so all real numbers except, they like giving exceptions in this book. When x is less than 10. Because anything less than 10 doesn't exist. If I put in 9 minus 10 is -1. They want the square root of -1. I can't do that. You can't take the square root of a negative. So this doesn't come into existence until 10. And then 10 minus 10 is 0. Square root of 0 is 0. And then 11, the square root of 1 is 1. And 12, the square root of 2, and so on. All right? So those are a little tricky. The domain, that's until you get used to it. Those are a little tricky. All right, and then the last thing that I want to show you on this note section in 10.8 is function notation, which sounds a lot harder than it is. It's pretty easy. Let me show you. It's doing something you've already done. It's just they present it in a slightly different manner. So if you could take a look at 87, they give you f of x is equal to 5x squared, and then they want you to find f of 3 and f of 0 and f of -4. Okay, so it's just plug and chug. You just put in the 3 for x. So 5 times 3 squared, order of operations, you do the squared before you multiply, 9 times 5, 45. So f of 3 is 45. F of 0, that's easy. 0 squared is 0 times 5 is 0. F of -4, oh, that's a little tougher, right? So -4 times -4 is positive 16, and then 16 times 5 is what, 30, carry the 3, 80. Okay. So it's just kind of plug and chug. And then we could do one more of those here. Let's do one more, quick one. What if it's a little harder of a function? Or here they said, hey, find f of -5 for this function, for f of x equals 10 over x. So then we're going to put in a negative 5. So f of negative 5 is equal to 10 over negative 5, which is negative 2. Now it's a little tricky because they use this, parentheses, which you're used to that as multiplication. But it's not multiplication. It's read f of negative 5. It's a fancy way of writing. F of x is a fancy way of writing y. So y equals 10 over x is sort of a synonym. Function notation, they use f of x, all right? And so then let's do one last one here. F of 29, when f of x is defined as the square root of x minus 4. So that just means we're going to put in a 29 where you have x, and then that's the square root of 25, and then that's 5. All right. Okay, so hopefully that's easy peasy lemon squeezy. It's doing what we've already done in the past with substitution. It's just they're asking it in a sort of weird way, f of function notation. All righty.